Worksheet 2A, question 9A. We're solving for velocity. We have lambda equals a lambda naught square root 1 minus v squared over c squared, and we're solving for v. I'm going to rewrite this because we have the radical sign again, and we don't see it in brackets, exponents, division, multiplication, addition, subtraction explicitly. So I'll rewrite it using exponents 1/2, which is equivalent to root square root. Again, we're solving for v, so let's take a look at the order of operations. It looks like if we want to isolate v, we have to, and we follow Sam and Deb, we look at the contents of the brackets last. So we have to take a look at this lambda naught, or wavelength initial, and this exponent 1/2. Is there any addition or subtraction happening to our v that's outside the brackets? No. Is there any multiplication? Yes, it's being multiplied by lambda naught, or initial wavelength. So we're going to divide both sides by initial wavelength, or lambda naught, and lambda naught divided by lambda naught is 1. So now we have lambda over lambda naught equals 1, which I'm not going to write, times 1 minus v squared over c squared to the power 1/2. Is there any division happening to v outside the brackets? No. Is there any exponents happening to v outside the brackets? And yes, we have the 1/2. So to deal with the square root, or the exponent 1/2, we're going to raise it to the power 2. I'm going to do that on both sides. And that 1/2 exponent and exponent 2 makes exponent 1. Now what we have is lambda squared over lambda naught squared, right? It's lambda over lambda naught times lambda over lambda naught, and that equals to 1 minus v squared over c squared. Now there's no more operations outside the brackets, so what we get to do now is repeat Sam and Deb, but to the contents within the brackets. So it's lambda squared over lambda naught squared equals 1 minus v squared over c squared. We don't need to write the brackets because there's no operations outside of them. Is there any subtraction or addition happening to velocity? Yes, there is. It's plus 1 being subtracted from v squared c squared. So what we're going to do is we're going to subtract 1 from both sides. You have to be very careful here, because this plus 1 minus 1 makes 0. So it's essentially 0 minus v squared c squared. The tendency is for students to think that that minus sign here disappears, but it doesn't. Is there any multiplication happening to v squared? Some would argue it's being multiplied by -1, so we can deal with that now if you like. We're going to divide both sides by -1. And that makes 1. So now what we have is lambda squared over lambda naught squared minus 1 divided by 1. So this lambda squared divided by lambda naught squared is a positive. If it's going to be divided by a negative, it becomes a negative. This -1 is being divided by a negative, and if a negative is being divided by a negative, it becomes a positive. So now we have v squared over c squared. Now, is there any division happening to our v squared, or v? Yes, it's being divided by c squared. So we'll multiply both sides by c squared. C squared divided by c squared is 1. We have to multiply this whole left-hand side by c squared. So it now becomes c squared minus lambda squared over lambda initial squared plus 1 equaling v squared. Now, is there any exponents on v? And yes, it's v squared, so we're going to square root the whole thing. So now our final answer, it's not pretty, but it's c squared minus lambda squared over lambda naught squared plus 1 equaling v. Now, because the left-hand side equals the right-hand side, we can write it as v equals square root c squared minus lambda squared lambda naught squared plus 1. Okay, and we can actually factor out this c squared. Since the square root c squared, it's c, and it's now minus lambda over lambda naught squared plus 1. Okay, a final answer here.